Dear my students, we are still under wave, under the part of standing wave, particularly on the case of transverse stationary waves in a vibrating string. And today we're going to look the concept called sonometer. Sonometer is nothing but an instrument which is used to study the relationship between frequency and length. The study of the relationship between frequency and the length of the string is studied by the instrument called sonometer. You'll be asked to define what is sonometer. I think that is not a very tough work to you. Now, the sonometer diagram look like this one here. This is the diagram of sonometer, where it consists of the following parts. One of the parts is this one here. This is a square or a rectangle box, which is called a hollow box. That means the one which is empty. But also have a string. This is the string with mass M. But also have a pulley. This cycle here is the pulley. But also have a body or a mass which is hanging, which is attached to the string. We have these ones here. These two, they are called traveling bridges. They are called traveling bridges. This is where we are going to adjust. This help us, traveling bridges help us to adjust the length of the string. Now, the thing which will be asked as sonometer concern is which principle that the sonometer works. The sonometer works on the principle of vibration of air, because sonometer is musical instruments. Now, how the sonometer uses this vibration of air to produce sound. That means how it works, the mode of action of sonometer. The mode of action of sonometer is not too complicated, because it is just what you need is to adjust the bridges. The bridges are traveling. Therefore, by adjusting them, you are going to give, or you are going to get ranges of what? Of length. Therefore, what you'll be doing is to adjust. That means maybe to keep them away or close. But by doing so, you're going to pluck here at this length. You are going to pluck at the length between the two traveling bridges. Now, plucking here, while the mass is hanging this way, that means you create tension. You create tension here. Tension will be created. Therefore, the tension which will be created here after plucking are the results. These ones will give out sound. The whole box will give out the what? Sound. Therefore, sound produced is not the same. It will depend on the length between the bridges. It will depend on the length between the bridges. Now, after these several investigations, scientists come up with the conclusion that frequency and length, they're related in the equation below. That means when the length was longer, low frequency was produced. But when the length was shorter, the shorter the length of the string, the higher the frequency produced on the whole box. But the longer the length of the string, the smaller the sound, or the frequency of sound was produced. Now, what can we conclude? we can conclude that frequency and the length, they are inversely proportional. By saying so, we can have the equation which is saying F is nothing but constant K over L. We can make K the subject, K equals to FL. That means the product of frequency times length of the string is a constant value. This tells us what? This tells us that if at all we have different lengths, we're going to have different frequencies in this ratio, in this formula. F1 L1 will be now equals to F2 L2, will be equals to F3 L3, will be equals depending on the numbers of the frequency and the length you have, Fn, Ln, etc., etc., etc. Therefore, this is how frequency and wavelengths relates according to the so-called solometer. And in most cases, you'll be asked to calculate frequency or whatever. I hope let us have a short break.